Okay, number 15. So we're looking at astrological signs, and they're going to do let's see, it's a chi-square goodness of fit, GOF, test. Now, they're saying that all 12 signs are equally likely. 1/12 of the time, so 1/12 of the total. Now, I added them all together and came up with the total is 4,344. So, what does that mean? Here we go. Our null hypothesis is all the signs should have a probability of 0.083, 1/12, versus at least one of them is incorrect. So what I'm going to do is I'm going to say, well, how about this? 4,344 and multiply that by 0.083. What do we get? And the answer is 360.5. So, approximately. And so all of these should be right around 360. All of these numbers should be, well, this one works, 360. Some of them are a little bit too high, some are too low. So that's why we do our goodness of fit test. Now don't forget, so our plan is a chi-square goodness of fit test. And don't forget, random, normal, independent. Don't forget, normal is we have over 5 in each of our groups. So we're good to go on that. Now, what I'm going to do is I'm going to put this list of numbers, all 12 numbers, into list 1. So into list 1. And then I'm going to put this number into list 2 12 times. Okay, let me do that. So I put those numbers in there, and I went to stat, test, over to chi-square goodness of fit. Observed is L1 and expected is L2. I put the numbers in already. Degrees of freedom is 11, one less the number of categories we have. We have 12 months, so degrees of freedom is going to be 11. And we calculate. So our chi-square number is going to be 19.9. That's how much we were off by. And let's see, the p-value isn't too bad. It's 0.046, but it is still below 0.05. So that means we're going to reject the null hypothesis in favor of the alternative hypothesis, which means that one of these numbers is off. Now, if you look at the calculator, there's that thing that says CNTRB. Now you can follow that. I'm using the arrow keys, and it'll tell me what all of the numbers were as far as how far off we were. And you can look at the one maybe that was the most, or one or two of them that were the most off. So I was looking at those. It looks like the first one is pretty high. What was it? First one was off by 4. And then, anyway, you guys can look at that. And maybe we can look at that when I see you on Tuesday, taking a look at those numbers, which one was the most off. So, there's that. Number 17, wrinkled peas, I guess. If that's what you want to study, that's cool. So let's do a chi-square goodness of fit, and I'm going to write down the null and alternative hypotheses to start out with. Okay, the null hypothesis is that we're going to have a 75% proportion or probability for smooth peas. So just use P of S for smooth, P of W for wrinkled, 25%. And then the alternative hypothesis, one or more of these probabilities is incorrect. Okay, and we're going to need to do random, normal, independent, and we're good with this because we've got, for the normal part, 133 and 423, both bigger than 5. So let's do the test. So there are 556 P's in total. So 556. So I'll multiply that by 0.75, and also I'll multiply that by 0.25 and see what we get. So this is what we should see in this situation: 417 versus 139. Now we got 423 and 133, so those are pretty close. I have a feeling that we're not going to reject the null hypothesis, but let's put them into the goodness of fit test. So what we're going to do is we're going to put these two numbers right here, 423 and 133, into list 1, and 417 and 139 into list 2. So when I did that, I got, here we go, chi-square, that number. How far were we off? We were only off by 0.345, not very far at all, with a degree of freedom of 1. And then our p-value is very high, it's 0.556. So we would fail to reject the null hypothesis and say that this is correct. No, we would not say that. We would say we don't have enough evidence to say that it's not correct. There we go. Fail to reject the null hypothesis. Done.